I'll be walking you through the various ways toolpath editing can help you leverage greater flexibility in the programming of your toolpaths and improve overall productivity using Fusion 360. In this first example, we are looking at a mold for a headlight on an automobile. And what we want to do is tidy up some of the toolpaths. We can see on this parallel strategy that in some cases, it's not respecting the contact point boundaries. In some circumstances, we can try to overcome this by editing the strategy to include touch or avoid surfaces, but this doesn't always give us an acceptable result and can often result in lengthy delays in surface selection and calculation time. Toolpath editing aims to make this process significantly more efficient. By clicking on the toolpath editing icon, we can then start to sketch around the toolpath segment that we wish to remove from the toolpath. The sketching of the polygon is created in 2D and is aligned to the view at the point of clicking the toolpath editing button. If you rotate the screen to get a better view of the area that you are sketching, you can easily navigate back to that view by clicking the Restore View button on the editing dialog. At the point that we are happy with the sketched area of toolpath, we have two options. We can either keep the toolpath section inside of the boundary or keep the remainder of the toolpath outside of the boundary. In this instance, we're going to choose to keep the segment outside of the polygon boundary. As we click on OK, we can see the toolpath trimmed with recalculated leads and links with a visible improvement to the toolpath leads and links. This results in significantly better surface finish and more efficient toolpaths. As we zoom out, it's important to note that recalculated leads and links are only applied to the areas I've trimmed, whilst the remainder of the original toolpath remains unchanged. The global undo, control, or command Z commands are still valid for toolpath edits. This allows users to undo any changes to any of the toolpaths alongside being able to edit the toolpath from the timeline below. The second model presents a situation where we may want to remove inefficiencies in the toolpath. In this example, I'm trying to machine the lugs with a tool approaching from the side without rounding off the sharp aspect of the lugs. To do this, I've constructed some geometry to help get a good quality toolpath across the two lugs. However, this resulted in an inefficient strategy with loads of air cutting. Toolpath editing allows me to trim away the excess I don't need and keep only the portions that are required to machine the lugs. I'll click the Edit Toolpath button and again start sketching a polygon around the area of the toolpath I want to trim. If I misplace any of the points, I can go back and drag them into a more suitable position. I can also add in some extra points if I feel I need to have a more accurate polygon, and similarly delete unneeded points. In this example, I'm going to keep the inner portion of the polygon boundary and click OK. It's worth noting again here that the toolpath is not being recalculated in its entirety, but rather the area trimmed and the leads and links recalculated for the trimmed portion. In this instance, I'm most concerned about machining time. If we have a look at the original untrimmed toolpath, the toolpath machining time is over 18 minutes long, which is significantly longer than the 11.5 minutes it takes to machine the trimmed version. This is particularly important when applied to processes like batch manufacturing. In this final example, let's look at how we can combine the best of two toolpaths together. Here, a pencil toolpath is used to machine this internal radius. However, when we approach the vertical region of the toolpath starts to fragment. The other problem is that we don't want to necessarily be running a toolpath vertically down a vertical fillet, which could ultimately lead to tool damage and poor surface finish. Using toolpath editing, we can trim off the top portion of the toolpath which is fragmented. This leads to a good pencil trace finish toolpath. I've also calculated a steep and shallow strategy, which we can also again edit using the Toolpath editing functionality. We can limit the toolpath again to only keep the inside portion of the polygon sketch, and we can then see the horizontal stitches along the pencil finishing strategy. This is all very good, but a lot of time we make multiple edits to step downs to make sure we achieve the surface finish desired. In this instance, we can edit the steep and shallow trimmed toolpath and change the step down to the required value, and when clicking on OK, we can see that the toolpath has remembered the trim applied as well as updated the toolpath to reflect the intent with the new step down required. As we look at the entire model, there are multiple areas I wish to remove. Toolpath editing also allows multiple polygon selection, which also inherit their individual trimming viewpoints. Here, I'm removing some further regions whilst keeping the remainder of the toolpath outside of the multiple polygon regions. Clicking the I button in the Toolpath Editing dialog in Fusion 360 will take you to the help documentation where you can learn more about toolpath editing and which toolpaths are currently editable. Hopefully these examples gave you some inspiration for how toolpath editing can help increase your toolpath efficiency and give you greater control and flexibility while programming.